Hello, this is the Math 159 Gould, Chapter 2, Section 3, about visualizing categorical distributions. So in the last two videos, we talked about graphs for numeric distributions, and then we talked about how to summarize numeric distributions. Now we're going to do a similar thing for categorical distributions. So first of all, I guess you should remember that the value of a categorical variable places the subject into a category. 1 second. So as an example, let's say that, I don't know, your categorical variable is favorite sort of ice cream. So we'll call the variable ice cream. What would the values be? Something like vanilla, chocolate, cherry. So this value of vanilla set means that that subject has as their favorite ice cream. The value of vanilla means that that subject has as their favorite ice cream vanilla. The value of chocolate means that that subject has as their favorite ice cream chocolate, and so on. Okay, and in another previous video, we talked about how there are frequency tables. So remember that in a frequency table, what it does is it counts the number of occurrences for each value. So let's quickly go to, what's it called? We'll switch over to the Pokemon data. It's my favorite one to use. And to make a frequency table, it's pretty straightforward. You go stat, you go tables, you go frequency. And let's choose as type 1. And then we'll choose frequency and relative frequency. All right, so you can see that, well, how many bug Pokemon are there? There are 72 of them. Okay, and that's 8%. Let's sort by frequency. So let's find the most common one, water. So water Pokemon are the most commonly occurring type. There are 114 of them, which is 14% of the Pokemon. So you might recall, we've talked about this before, that the most frequent value is called the mode. So in the previous example, what was the most frequently occurring type of Pokemon? Water Pokemon, because they have the greatest count or frequency. Okay, so anyways, let's talk now about what the bar chart is. The bar chart looks a lot like a histogram. Except it's for categorical variables. Histogram, I can't type. Okay, so a histogram, however, is for numeric variables. A bar chart is for categorical variables. And the bar chart, basically a bar chart is the graphic version of the frequency table. So what do I mean by that? Well, in the frequency table, remember, you basically have a count of how many occurrences of each value there are. So there are bars, and the heights of the bars are determined by the frequency of the value. So in other words, well, if there are 114 water Pokemon, then there is going to be a bar with a height of 114, which is labeled a water Pokemon. Can't spell Pokemon. Okay, so basically the bar chart is just a graphical representation of the frequency table. So we're gonna switch over to what's called StatCrunch, and we'll show you what that looks like. So you can see we have the frequency table for the type. So let's make a bar chart. So the bar chart is a graph, so we go to graph. Right here it says bar plot. You can say with data. We select the variable type 1. Say compute. And you can see in the bar chart, on the x-axis are the names of the different values. So over here you can see, I hope you can see my little thing, water on the right. Okay, and here are the water Pokemon, and you can see the height of it is about 114, right? Because 100 is right here, and 100 is a height of about this. So you can see it goes over 100, about 114. Okay, so basically the bar chart is just a graphical representation of the frequency table. I think you can have it sorted because they're all. If you look, the way it works is that it does it in alphabetical order. If you make it a little bigger, you can see there's bug, dark, dragon, electric, fairy, fighting, fire, flying, ghost, and so on. Water's at the end, right? It goes in alphabetical order, so you can see that water Pokemon are the largest group, followed then by normal Pokemon, and then followed by grass Pokemon. And if you go, you can see that you get the same results when you look over here at the table, right? Water is the most with 114, and normal is 105, grass with 78. So basically, this just instead of like looking at the numbers, you get an idea of the relative size. Like you can tell that the water Pokemon are pretty close in size to the normal Pokemon. One's a bit bigger than the other. And you can see, for instance, that flying Pokemon are tiny compared to everyone else. If you don't want this to be in alphabetical order, you can choose order by count ascending or count descending. That will so there you go. Now you can see that it starts off with the smallest group, flying, and then ends with the largest group over here, water. And then you can see in between. So I prefer to look at it this way as opposed to in alphabetical order because it makes it a little easier, and you can sort of like see how they get bigger or smaller as you go on. Okay, so let's change back to OneNote. Okay, so that's the bar chart. It's probably the best graphical representation for categorical variables. You might be familiar with piecharts, but piecharts are pretty horrible. I recommend you use the bar chart instead. And I'll show you why. So let's go back over to the Pokemon dataset, and what we will do is we are going to make a pie chart of this. So I'm gonna move that out of the way. So we'll go graph, pie chart with data. We'll choose type 1, compute. And so here's the thing. We're going to compare these two. When you look at the bar chart, it's pretty obvious how big one is compared to the other. So let's look at, for instance, water Pokemon versus psychic Pokemon. Now, if you look at the heights, you can just use your finger and you can see that the psychic Pokemon are about half the size of the water Pokemon. And you can just do that by like taking out a ruler or using your fingers, and you just like, I'm putting my fingers up and measuring the height of psychic Pokemon, and I move it over to water Pokemon, and I can see that it takes about 2 of those, right? So it's about double half the size of the other. Okay, now if we go over and look at the pie chart, however, let's clear everything. It's a lot harder to do that, and on top of that, it's a lot harder to read. Like, even if I'm making it big, I still can't see what group this is right here. However, if I hover over it, I can see that it says fighting Pokemon. And let's look at, say, water and normal. It's a little hard to see which, or let's compare bug and water. Right? They're right next to each other. Here's bug over here, and here's water over here. It's like, is water double the size of bug? I'm not really sure. But if you go back to the bar chart, it's pretty easy to see. You can see bug is right here. It's about 2/3 the size of water. That's not so obvious when you look at the pie chart. You can make it a little easier by putting count ascending, but still it becomes really hard to make comparisons. Like, bug and water. Bug we found out about 2/3 the size of water. It looks like half here. So the lesson to learn here is that you should use bar charts for what's it called? Categorical variables, because you can compare the heights a lot easier. I want to point out it looks like a histogram, but a histogram is for numerical variables, so I have an example of each of them here. On the left is the histogram of HP, and on the right is the bar chart of the Pokemon type. So for a bar chart, this dragon bin right here, that counts how many subjects are type dragon, which if you hover over it, it says there are 27 of them. I selected it. However, remember over here, when we look at the bins for the histogram, that's the subjects that have between 75 and 100 HP. Okay? And the one to the left of it are the subjects that have between 50 and 75 HP. However, fighting Pokemon over here have nothing to do with ghost Pokemon, right? Like, they work differently. So bar charts are for categorical variables, histograms are for numeric variables.